Right, recording. Welcome to Morning Report. Today I am continuing to fill in the details of the proof schema with org mode. So I have previously recorded something, but the video, the screen didn't appear, only the camera and the sound. So I'm gonna recapitulate what I have done. So I have now a Doom Emacs. Let's quickly summarize what I've done. I have a Doom Emacs, and here I have those files, org files. Org with the command org not find, I can list the nodes, and those will be the tags, equivalent of tags in some other mathematics, knowledge management system, maybe proof management system, you can say. And for example, with this one, when you enter, the editor opens up the file itself, and this is a simple org file, and you can use LaTeX inside it. The cool thing is that when you now say org UI mode, it'll open up a tab in your browser, and it'll visualize the files. And as you can see, for example, this 726 is connected with several other nodes, for example 728. And if we go to org with the command org.find 727, 726 actually, 726, we will see the link inside it to the 727 node. So inside this one, and you can juggle it. Inside this one, yeah. You will see this is the. Okay, let's naturally use this. I'm now inside this central node, and those purple ones are links, and when you hover of them, you will see the preview of the link of the node. And for example, this one is the definition of a morphism of projective geometries, and so this will provide us a way to visualize the dependency, the relation of the facts listed in the book, and we will extract some subset of those facts that is required for the proof of the Desargues theorem. So that is the main goal, the current main goal of the of my graduation project. So in the long run, we are trying to formalize the theorem. And this this part that where you extract the proof schema, and yeah, extracting the proof schema is very crucial. If you don't do this, things will become very messy, and this proof schema requires a careful bookkeeping of the facts and definitions you use in the proof. Okay, here I have the general, the final result. So this is the result we will eventually prove, formalize in the in the project. Yeah. Let me see. Does this show how much time I've spent? Nope. Anyway, so here this week I want to continue backwards, and yeah, let me explain this way. So what I have done here, so this is the end result, and here I have only the crucial part, that is visible here, the definition of hyperplane embedding. That is the main crucial thing visible in the proof and in the theorem total. Yeah. So the proposition does not say much for every vector space V of dimension at least 3. So vector space, dimension of a vector space, those are fairly straightforward, I think. And PV, projectivization of vector space V, this is also pretty much done. I've written a structure that will allow us to represent the projectivization of vector spaces as projective geometries. I will explain also that in the later part of this video. So this is also we have, and I should also add this here. But what I have done is to backtrace the things I need if I start digging from this hyperplane embedding thing. And when I do this, I go to the definition of it, and here you will require the definition of a morphism, because a subspace embedding is a morphism, and the conditions are listed in the next element of the book. That is a proposition that asserts the equivalence of some conditions. So, and then it says that if the image is a hyperplane, so we also need the definition of hyperplane. And when you go to hyperplane, I think it was fairly elementary. A hyperplane of a projective geometry G is a subspace, so we need also the definition of subspace. Maybe we should I think this part is fairly there's nothing too dark left here, I mean, the definition of subspace it's there and it'll be transcribed here. That's not a big problem. But the logical chain of implications is lacking, and there's nothing I have transcribed, and even I have discovered here yet. So I will, in this video, I plan to backtrace the logical chain of implications. Okay, so I'm for now I am passing these lacking definitions because they're not crucial for now, and this seems to be naturally because I'm focusing on it, the central node. So this way of thinking, visualization is working. I mean, okay, so again, 844, the corollary. Okay, so this is a corollary, and I mean 844, and this is the corollary of the theorem stating if G admits a strict subspace embedding into some projective geometry G tilde, then G is Argusian. So this is the theorem, and the proof is a one paragraph proof. Okay, so maybe we should write this. Right, so so what's the shortcut for this? Space NRF, space NRF, and I'll say 8.4.3. This says if G admits a strict subspace embedding, so I will so subspace embedding is 826, a strict subspace embedding, by the way, strict, and I will insert ogrom, insert, yeah, so this is full. I'm gonna unplug it. Okay, so I'm gonna insert the 826 here, and I will change the I will change the name of the link as subspace embedding, and then I'm gonna add the square bracket back, subspace embedding into some projective, by the way there's a dash here, subspace embedding into some projective geometry, G tilde G, so I will say tilde G, I think. Then let's enable autofill mode. Then G is Argusian. So maybe I have mistyped also the word Argusian in the corollary. Let's see. Find 844. Argusian. Gaussian. Gaussian. Okay. Fairly tricky, this word. Okay, so let's return to the 843. So this is done, right? And should I write the proof? I don't think so. It's a long proof. We first remarked that there exists a projective geometry G bar which contains G as hyperplane. Let H be any hyperplane of G. One chooses a point Q in G bar minus G. Then G prime is defined to be H, and then this logical disjunction symbol. Q is a hyperplane of G bar with G intersection G prime equals, well, this is cryptic, at least for right now. Moreover, one chooses a point O bar. Okay, suppose that points G and BA are given. We put A prime. Okay, is it definition? There's a construction here. So so it says L bar so is this G bar a convention, or I mean a defined thing, or is it defined here? And one obtains phi A prime A PR, so there's the operator PR. Projection is a projection. Moreover, by 831, the point Z is the center of phi A bar. Finally, phi A bar is an endomorphism of G, having H as axis by 831. So 831 is required. Okay, let's just not try not to understand everything, but just extract the dependency for now. So I will need 831. So 831 is okay. So 844 is here, and one page back 831, and one page again 831 is here. Okay, nice. This portion, let's transcribe this. 831 space N or F. I'm also trying to familiarize myself with the shortcuts. 8.3.1, this is a proposition. It says let H subset equal G. This 8 is too far from the option key, and I mean with respect to my own keyboard. So G and G bar okay, so there are some suppositions here. It says above, in this section we suppose that a projective geometry of dimension at least 3 is included as hyperplane in a geometry G bar. We then construct for any hyperplane for any hyperplane h of g, okay, we then construct for any hyperplane h of g a bijection phi from g bar to eh onto the set eh of all non-empty endomorphisms of G having axis H, which becomes a projective geometry by 2, 1, 5. So okay, let's return to the proposition. Let H subset equals G subset equals bar over bar. Was it over bar? Over bar G and right G be inclusions of hyperplanes and O bar over bar O in G set minus autofill mode set minus G period. So this is in over bar G, by the way. Let's see. Refresh. 8.3.1. Over bar is not a thing. Bar work. Fresh. 831. Yep, so it's bar, not over bar. Okay. So we have forgotten here subset equal the inclusions of hyperplanes and in yep, bar O bar in G bar minus G. So it says we consider sorry, we consider another hyperplane G prime of G bar with G cap G bar equals H. It says, and it continues, and bar O not in G bar, I mean G prime. The map pi colon ec PR operator name, PR operator name, PR G comma G prime, and for the superscript we will have bar of O. And it references 8.8, I mean 6.6.9 is an isomorphism from G to G prime. It says for any a bar in G prime G bar, we define so phi of bar of A defined to be operator name PR G bar, okay, G superscript bar of A composed with operator name PR and G bar this is long. Okay, okay. And this is equal to, because of the definition we have above, operator name, the first one is the same, bar of A circle pi. Right, then one has, here comes the punchline, phi of A bar in, I don't know, this I think it's script, but I'm not sure. Why does it respond like this? This is a simple so stupid. Okay, just want to, yeah, H edest one gets a map phi from G bar to math script E. Yeah, again, I don't know why it does that. Okay, this map phi is bijective. Wow. Moreover, over for A bar not equals O bar, the point operator name PR G, so the math enclosure should be there for it to respond normally. Operator name PR of PRG, O bar of yes of A bar. Nope, this is a normal parentheses. Okay, is the center of phi of phi A bar CF CF 8.6.6.8 for P for operator name of PR G O bar O. Okay, let's see. This is 8.3.1. Should refresh. It's almost okay, but there is a problem here. The map, so we never close the dollar here, I think. Yes, an isomorphism, one has looks okay. Yeah, this also looks okay. This map is bijective, moreover. Over for A bar, not well. Equals, I think, a command, a normal command, but anyways. The point is the centered center of, fresh again, center of phi A bar, it says. Okay. So this was the proposition mentioned in in the proof of the theorems 8.4.3. Let's also insert it. Find. Yeah, this was the theorem, and in the proof we require maybe I should also write the proof, but not now. I'm just okay. So when I write it, I can insert the proposition. Okay, one other thing I want to mention. So that's the workflow, adding prepositions and linking them one another. This is the workflow. You can see the linked references here. Yeah. Okay, so I am keeping this org directory as a Git repository. So this one, and let's see Git status. So we have included new files, and this is a modified, it says. Okay, maybe I should have said git def. Yeah, so we have fixed the typo there. Okay, git commit fix typo in the word. Arguer Arguesian. Add two more dependencies. Well, yeah, two more is fine. Fix typo in the word Arguesian, add two more dependencies. Okay, and git push origin main. Okay, so this is my workflow. I should also exit. Control C, Control X, Control C, yes. We can leave this. This is not working now. Nice. And I think I can finish this episode of the morning report here. I also have the plans of setting up nvim as the lean editor. I think it will be the tomorrow's subject matter of the episode.